Good morning, everybody. Welcome back to lecture number 22. Today we will probably recall some of the problems from previous lecture. What did we mention? There is two maximum power impedances. One is complex, which is the conjugate of Z Thévenin. One is real. If you're allowed only to connect resistors, it has to have a value of absolute value of Z Thévenin. How to calculate it? It's the square root of R squared plus X squared. Get it? So if you get a complex number R plus J times X of t, the first maximum power would occur at RT minus JX. You just change the negative of the J, replace every J with a negative. Or if it's real, then it will be the square root of R squared plus X squared, or use the calculator to calculate the command absolute value. Okay? Looking at this example, Z Thévenin was what? 50 plus J? 50. What is Z Thévenin? What the power transfer occurs at? 50 minus J, 50. And this is if it was only complex. And what is the current? The current is VT, which is 100 angle minus 90, which is V Thévenin. We calculated last time. Divided by 50 minus J50 plus 50. So what we had is V Thévenin, 1 angle 90, and we had what? A box of 50 minus J50. So what's the maximum power occurs at? Occurs at a box of 50 plus J50. Get it? So what's the current? Plus minus I of A, they call it here A, equals V of t over 50 minus J50 plus 50 plus J50. It will be what? 100. Is it 100? Yeah, 100. 100 angle 90 over 100, which is what? 1 angle 90. No, minus 90. V Thévenin is minus 90. What is 1 angle minus 90? Mishal, what is 1 minus 90 in the calculator? See, you didn't bring calculator.
Should be minus J.
Minus J. Get it? Okay? What's the unit? Amps. So we have a minus J here. So what's the maximum power? You go back to the formulas of the power, okay? Always print this before the test, okay? I don't care if you bring it, this sheet. Well, if you're that smart to remember I told you this information, then you deserve to bring it in the exam, okay? Don't tell Dr. Ahmed or Dr. Adi. This sheet, you see this sheet? Mm-hmm. No, the summary sheet. Summary sheet, this sheet. Okay, it's bad. Today we'll talk also about what? Electronics, inshallah, okay? So, if you are smart enough, YouTube, don't listen, you can print this and bring it in the test, okay? That's the only probably, and don't tell me, okay? Just tell me you said that in the lecture. If you're smart enough to figure it out. Most people will forget, because they don't watch the YouTube. You see this? What was the formula? I squared Z, okay? For the real power, what's the formula? I square RMS times R. So use this formula. If we use this formula, what will be the maximum power transfer? The maximum power transfer will be I square RMS, which is 1 over square root of 2. The current magnitude is what? Is what? Absolute value of minus 1. RMS, you divide by square root of 2. You take this quantity. This is I RMS, okay? I A RMS. Get it? It's the absolute value of the phasor divided by square root of 2. Use your calculators. What is your calculator? What is your calculator? What is your calculator? And then you complain about the test, okay? Please, ya shabab.
0.7.
If you're here, maximize the benefit of the course, okay?
0.7.
Do it the calculator. Who doesn't have it? Yeah, please use it, okay? You see it's 50 times 1 over square root of 2 all squared. And you get 25 watts. But if it was purely resistive, we are allowed to connect square root of 50 squared plus 50 squared. What's the answer? Well, I can see it here. It's 70.7 ohm. So I can calculate the current. If we calculate the current, it will be what? Vt over 50 minus J50 plus 70. 70 plus 50 minus J50. So the current phasor will be, in terms of magnitude, lower. Lower. It will be, what is IB? B means part B. A means part A. Vt over 50 minus J50 plus 70.71. Which is 100 minus 90 over that number. Which is 120.71 minus J50. What's the answer? If you're not fast enough, give me back my calculator. If you're not fast enough, bring your calculator this time, please, okay?
Syntax error.
There is nothing called syntax error. It means your calculator is not good. Change it.
Negative 0.3 minus
And
0.
ortho. And who?
0.67 minus 0.35.
Yeah, Shabab, this is very important. 120.71 minus 50J. What's the magnitude? It's phasor, 0.765 angle minus 67 amps, okay?
Yes.
So you take that number, IB RMS is 0.765 divided by square root of 2, okay? If I calculate the maximum power for part B, it will be 0.765 over square root of 2 squared times the resistive load. So you take this 0.765 divided by square root of 2 squared times 70.71. It is a less power. It's 20 watts, okay? 20.7. I don't care about numbers, okay? Because when you have an MCQ, you should be fast enough to figure it out. Get it? So what do you notice? The maximum power, the real maximum real power occurs at if we connect complex load or in resistive load.
Complex.
Complex. 25 is bigger than 21. For the same, is this the same problem? No, that's a different problem. Okay, let's do. What's the first step? Always I told you about Thévenin equivalent circuit. By looking, we kill the source. So we kill the voltage source. So it will be 100 parallel with J100. What's 100 parallel with J100? I'm not going to write it now. We can do it fast by calculator. It's 1 over 100 plus 1 over J times 100. And then you take the inverse. Okay. This is equivalent plus 50 minus 25J. What's R Thévenin? 100 plus J25. Did you get it?
Yes.
It is this 100 parallel with J100 plus 50 plus minus J25.
Yes.
How to calculate V Thévenin? What's the fastest way? Use. Okay, remember, what did I tell you? If you connect R Thévenin, you see this resistance. But V Thévenin, there is no current flowing into the open circuit. So can we use VDR? To calculate V Thévenin, it's equivalent of saying the voltage drop across the 100 ohm resistor. Because there is no current flowing here. Now we use VDR, question 1 in the test. 100 over J 100 plus 100 times. Get it? Do you see the VDR? Do you see the VDR? Fawaz, do you see the VDR? Hatem, do you see the VDR? Why it's a VDR? Because
Same current.
for the open circuit, 100 is in series. With J 100, let's do it. What's V Thévenin? 100 over 100 plus J times 100 times 100 angle 0. And you will get 50 minus 50J or 70.71 angle minus 45. If you want to calculate Norton, you can use source transformation. Basically, you divide V Thévenin over Z Thévenin. Get it? That's a simple example. If I bring this in the quiz, can you solve it? Okay. Now, what is the maximum power that can be delivered? Again, it's 100 minus J, 25. Or, if we want to connect resistive load, 100 square plus 25 square, which is 103. This is if we connect the two resistors, okay? Now, let me ask you a question. When you calculate the power, do you use this circuit or you use Thévenin equivalent circuit? Use Thévenin equivalent circuit. Get it? Do not reuse the big circuit. Khalas, we got rid of it. So to calculate the maximum power, you connect the load to Z Thévenin. And you put the voltage source of V Thévenin and you calculate the power. V, you calculate same. I equal V over Z plus Z max. And then you do IRMS. And then half. And then the power is, the real power is IRMS square times R. Get it? I'm not going to solve part exercise 5.15. Okay? Now we have 512, 513, and 514. I think we were talking about 514. It is solved here in front of you. So to calculate the man, okay, you're lucky. But here is a question: did we solve this? This was a long time ago, right? Okay, I'm not going to solve it. But this is the one we're solving right now, 514. It is solved here. To calculate the maximum power, you can see from the circuit, V Thévenin over R Thévenin, you connect to it. One time you connect, 100 minus J25. Then you calculate the current. What's the current? 70.7 angle minus 45 over 100. Basically, they will cancel, which is going to be 0.3536 angle minus 45. This is the peak or the max? The 0.3536.
The max.
The max. So to get the RMS, do you divide by square root of 2. And then you square it. And then you multiply it by the R only to get the real power. Remember the formula, the only paper that I allowed you to bring in the exam? Get it? Dr. Atiyah complain, or Dr. Ahmed, don't tell him, okay? Don't tell him. Because this is very important. Please, this is the only one you're allowed to bring. I'll try to put it in the test, okay? Not for the quiz. Okay? Any question about Thévenin? So we have problems remaining. My plan is to solve the remaining problems in the help session, okay? So we have this problem 513. We have 512. We really don't have time. I'm so sorry. I cannot solve it. We're really late in the manhaj, okay? تأخير في المنهج.
When is the help session?
Oh, before the test. We're going to have this time 2 help sessions because we didn't do well in major 1. My goal is for you to get average of 80 and above. Tamam? Then we're going to have 2 help sessions. Okay. Any question about chapter 5? So now we're celebrating because we're going to a new chapter. We're talking about electronics, okay? Did you start the electronics lab or not yet? No, the op-amp. Did you get the op-amp? Okay. I don't think you will have it. Anyway. ايش هو الأوب-amp يا شباب؟ open Wikipedia page. افتحوا ويكيبيديا بالعربي op amp. نبغى تعريفه. Op amp. Operational amplifier. While I'm downloading. I'm not going to start with slide 1. This is later. I'm going to start with here. You see now we changed the color to green. We're talking op amps and diode. What is op amp in Wikipedia?
مضخم إلكتروني الجهد.
Okay, can you read the first paragraph or the first 2 sentences of the
Yes.
Wikipedia article بالعربي?
مضخم إلكتروني الجهد على الكسب باقتران مباشر وإشارات دخل تفاضلية.
اوكي. يقول يا شباب، يقول اسم المضخم العملياتي هو مضخم الكتروني للجهد. مضخم الكتروني للجهد means it amplifies the voltage. عالي الكسب means high gain. باقتران مباشر direct connection. وإشارات دخل تفاضلية. What does تفاضل mean يا شباب؟ تفاضل إيش معناه؟
rate of change.
تفاضل هو الاختلاف. الاختلاف. أساساً الدerivative is nothing but a subtraction. But you do it in a continuous basis. Subtract in a continuous basis. فالoperational amplifier هو يطرح الانبوت من الاوتبوت ويضخمه. That's it. Operational amplifier, it's a device that subtracts whatever it receives and it amplifies the difference. Think of an error. If you have an error signal, how do you know this error signal can be detected? مثبت السرعة for example. أنت ماسك طريق الرياض مثبت على كم الحين؟ 143 ما يمسك ولا 144 يمسك؟ متى كم يمسك سالم؟ 140. خط كم يمسك؟ 145. أنت مثبت على 144. The moment you change from 140, the moment your car starts to be 145, what will happen? The op amp, it is the op amp, will subtract 145 minus 144. This is 1. It amplifies it to be what? 1000. So this 1000 signal will drive the controller enough to reduce the speed. Get it? Get it? If there is no amplifier, can the 1 be detected by the control signal? Not much. Okay, if the difference in speed 0.1, انت ماشي 144.1 والlimit is 144. What's the difference? 0.1 times 100 times 1000 is what? 100. Is 100 enough to control compared to 1000? Of course the action will be more aggressive على ايش؟ اللي هي ماشي 145. The more the error gets larger, the more it's amplified. This is one of the basic applications of the operational amplifier.
Is this like the gain in Simulink?
It is the gain in Simulink. The triangle, actually this is one of the things where Simulink cheated from electrical engineers and they got the gain. Okay? They got the gain. And this is how it looks like, Shabab. It has a positive input, a negative input, and whatever voltage measured here, it will be amplified in the output. I will explain it more. But all of you have this calculator. By the way, this calculator can solve, this is the best calculator, 991 ES. How the calculator has addition, subtraction, integration, how they do it. Or if you have speakers, how the speakers are amplified. If you increase the volume, how the volume gets louder. In this chapter, we will learn about the characteristics of the op amp. We're going to talk about negative feedback. Did you talk about negative feedback in mechanical engineering?
In control, there is negative feedback.
How did you study the control course and you're still taking EE234?
I'm from aerospace, so...
Okay. Because mechanical you didn't study. You're aerospace?
Yes.
Okay. So you did control.
Yes.
So you guys are going to do control next semester when you finish this course. That's why you do control. Okay? Because we really need to understand the negative feedback concept. If you have a negative feedback, your controller will be stable. We're going to some point in the amplifier, op-amp, to analyze, and then we're going to use op-amp to design useful circuit, integrator, differentiator, adder, subtractor. And it's going to be used in an instrumentation amplifier, القياس. How do you measure the voltage between 2 points in the pipeline? You need control signals. You need op-amp to amplify the difference between the voltage. Okay? So in this chapter, we introduce a very important device known as the operational amplifier. وش تعني بها يا شباب؟
المضخم العمليات.
Get it? 99% of electrical engineers in Saudi Arabia, they don't know about the Arabic correspondent of op-amp. Find application-wide rate of engineering, okay? The operational amplifier, what's inside the chip? It's inside of 30 BGT. BGT is transistor, okay? Okay? Or FAT. It's two different types of transistor. You don't have to know about it now. And it has resistors. And it has capacitors. Many things inside, okay? These components are manufactured together. Concurrently, يعني إيش? One time manufactured on a single piece called chip. حلو? Circuits manufactured in this way are called integrated circuits. Integrated circuits, الحين هنا في السعودية we are going into manufacturing the chips. سامي والإلكترونيات المتقدمة. You know الإلكترونيات المتقدمة في الرياض? That's what they do. They manufacture op-amps. And not op-amps, but more advanced stuff. Get it? In KFUPM, we used to have a lab that manufactures printed circuit boards where you have resistors that are flat. يعني مو هو زي اللي في اللاب عندكم resistors that are flat. Currently the operational amplifier, or now we're going to call it خلاص ايش op-amp, okay? Refers to the ICs that are employed in a wide variety of applications. It's mainly started from analog computers. The 1970s computers, when they were big, it used to work using electronic circuits. Now everything is digital, okay? It was performing operations back that time, which is still being performed today using calculator. That's why they call it operations. So the word operations meaning addition, subtraction, integration, etc. The word amplifier meaning the output signal has usually higher voltage than the input difference. Okay? So let's look at how it works. So this is the inverting side. This is the positive side. What does it mean? And focus with me, ya shabab, because many students, whenever they see op-amp in the exam, they get scared. The op-amp has a triangle shape, okay? Minus and plus. It means if I put here 5 volts, battery of 5 volts, if I put here a battery of 3 volts, what is being input? 5 minus 3. So we call the negative inverting input because it inverts 3. It actually sees minus 3 here and it adds it with the positive 5. And then it has infinite big output. However, we see it's connected to minus V supply and plus V supply. That's the only time you're going to see it. هذه it powers the amplifier. It gives the amplifier a power. Meaning, no matter what's your input, your output cannot exceed V supply minus V supply. Let's say V supply هي 5 volt وماينس V supply هي minus 5 volt. What's the maximum possible output here?
10 volts.
10 volts. ما تقدر تطلع output أعلى من السبلاي. If you have this calculator, what's the maximum voltage? Look at it. It says it's 1.5 volt battery. Can it generate a signal larger than 1.5?
No.
No. The same concept. For the solving this in solving this op amp, we usually drop the supply voltage, okay? We don't care about it. Okay? Get it? Now, if you look at the schematic, which is I really don't understand, but these are the transistors, okay? These are transistors, these are resistors. There's no capacitors here. Oh, there is one capacitor here, 30 picofarad. What is pico? 10 to minus 12, okay? And it has lots of components. The red one here is the offset null. The red here is inverting input. So inverting input is nothing but two transistors opposite of each other. Then we have offset null. Then you don't have to know about it. The only thing you know about, what is inside the op amp? Transistors.
Using the amplifier, shouldn't the maximum voltage be 3 or because?
No, that's, for this it's not plus V supply, minus V supply. Here you have the whole thing is 1.5. In the plus V supply, minus V supply, you have 5 volt, but you connect to the negative of it. So that's why how you get 10 volt. Do you remember in the lab you have 5 volt, and then you have, if you connect it here, you'll get minus 10 volt, or plus 10 volt, which is actually 5 minus 5. It's like you put two batteries opposite of each other. Get it? But this one is a one voltage source. This has, think of it as 2 voltage sources. So it's كان بطاريتين عكس بعض. Don't worry much about it. We have better stuff to worry about. But this is the supply. We all know shouldn't exceed 10 volt if you have a 5 and minus 5. Okay? Yes.
So, Doctor, what's the main difference between the amplifier and capacitor?
The capacitor does not subtract the difference. The amplifier subtracts the difference. The capacitor doesn't have any input. It's a passive device. You don't need to power. Capacitor, you don't need to power. You connect it to whatever system you have. Okay? No, it doesn't amplify it. Capacitor, if you connect it to a DC, it will store the voltage. That's it. If you connect it to AC, it depends. Depends on the phase angle, the phasers.
The transformer.
A transformer is an inductor. Transformer, the one we explained, it's 2 inductors. What's happening is if you apply 110 volt, you might get 240 volt, but you're changing the voltage level. But it only deals with AC. It doesn't deal with this. The op amp deals with DC. Get it? الأوب أمب يا شباب يشتغل على AC ولا الDC عندنا في الكورس هذا؟ So far DC, okay? Forget about AC. No phasers, خلاص. Phasers, chapter 5, Thursday, okay? Let me talk a little bit more about it. In the lab, you always have this half circle. It means you should start counting clockwise. So this is 1, 2, 3, 4, 5, 6, 7, 8. عنده 8 رجول. تمام؟ لما تعد رجولة تعد من الدائرة اللي في النص في الداتا sheet. And it tells you one is offset null, inverting input. This is minus V, this is plus V. So 4 is the negative supply, 5 is the positive supply. هي توصلي مع بطارية 5 فولت، هذا توصل مع بطارية minus 5 فولت يعني تقلبها. Get it? So 5 minus 5, you get plus 10. You power the device.
So we can't connect 10 and 0.
You can do that. Some people do that. Connect here the ground and here connect 10. As long as you provide a voltage difference of 10 volts, for example, you can run it. Or 2.5 and 2.5. It depends on the manufacturer, okay? What I want you to learn is whenever you see an IC, don't get scared. Go to the data sheet and whenever you see this half circle, you start counting the numbers counterclockwise. Okay? What are the ideal characteristic اللي هي الخصائص المثالية? It doesn't exist in real life, but we can see it. The first feature is it has infinite input impedance. What does that mean? When I tell you very high impedance, it means it acts like an open circuit. Note the word infinite input impedance. بمعنى, if you have an op amp, minus and plus, and you connect to it a resistor and a battery, okay? Let's talk about the positive. Here maybe we connect it to, let's say, a battery of then a resistor. This is R1 equal 1 kilo ohm. And then here we connect it to another system, for example. What I mean by high input impedance is the voltage here would force all the current to go outside here, okay? Meaning no current is allowed to go inside. ما بيسحب تيار من النيجاتيف والpositive point. What does this imply? It means there is no way a current will be here, so I equals 0. If you connect it this way, الجهاز ما بيسحب current. Get it? So if you connect it to a resistor and a battery, forget about this. This is the positive. There is no current that flows inside because it has infinite impedance. Absent, I'm sorry. Okay? You want to attend the next lecture at 11?
I have another lecture.
Okay, do the trick. Attend 11, get an attendance, leave, go get a late there. Get it? Get it, ya shabab? But you have to be there at 11, okay? Get it? ما بيسحب تيار. بيمرر التيار whatever is connected outside. ما بيدخل تيار داخل. That's infinite input impedance. Zero output impedance بمعنى whatever you connect to it at the load, it's capable of providing whatever current it needs. يعني بيطلع تيار. ما بيدخل تيار بس بيطلع تيار عادي ما في مشكلة. بمعنى إنه acts إنه whatever current leaves the op amp is gonna go to the load. Get it?
So, كيف ما يدخل التيار ويطلع من التيار؟
السبلاي بيطلع لك. السبلاي
من فوق تحت.
السبلاي بيطلع لك تيار. بس إنه الانبوت سيجنال ما بتدخل كتيار. بس الاوتبوت it has zero impedance, zero output impedance. ايش معنى zero output impedance? It can deliver whatever current is needed. Okay? If you look at, for example, this slide, يعني كأنه voltage source. Okay? Output resistance equal to 0 كأنه voltage source بيطلع لك current based on the load you connected. مو current source يعني كأنك موصل يعني هو كأنه بطارية لأن أساسا في supply. whatever load you connected بيعطيك التيار اللي تبغاه. This is what we mean by internal output resistance of 0. لا تناظر اللي تحت. YouTube, don't look down. What we mean by zero output resistance, it means it acts like a battery. So it can deliver whatever load you connect, it will provide enough current. Okay? Now we are always limited with the supply voltage. Okay? VCC and VEE. Okay? Plus 5, minus 5. 5 minus minus 5, plus 10, for example. The third and the most important feature is the open loop gain is very large, 9999, okay? يعني إذا هو مثبت السرعة for some reason مثبت السرعة measured the difference of 1 kilometers per second, which can be translated to 1 volt, for example. The amplifier has a gain of big number that the output will be 9999. يضخم الديفرنس. The difference is 1, بيطلع 999. Open a big number. But there is a problem with it. We are always limited with the 10 volt. صح? What does it mean? It means the open loop gain ideally is very large. But in reality it's limited with, again, the supply. Note what is the equation of the output. It is the gain times V1 minus V2. Yes.
Why do we need to amplify the,
لأن أنت في مثبت السرعة. خل مثبت السرعة مثال. If your speed is 145 عشان ما يمسكك ساعة 144 and you're 144, if you are 144.1, what's the difference? 0.1. 0.1 times 9999.
I mean, the computer can deal with the 0.
Forget about computer. We're talking about before the existence of computers. Or we're talking about facilities where analog circuits exist. Instrumentation. معامل سابق وهذه مو كلها فيها كمبيوترات. في أشياء مسوينها من السبعينات. أتحداك تركب فيها كمبيوتر الحين. والستينات ما تقدر. That's why we need to learn it. كمبيوترات موجودة على الأشياء هذه بس إن البلانتات فيها أشياء analog. circuit.
بما أن الفولتج اللي راح يطلع من الأمبليفاير يكون عالي، هل لازم اللود اللي بعده يكون ضوء مستقر؟
Forget about the load. When we connect a circuit, we analyze separately. The important feature about this is the open loop gain. بمعنى إذا ما وصلت شيء من الأوتبوت إلى الإنبوت open loop يعني كذا سادة infinitely high ideal. بس خلنا نقول يعني معليش اعذروني على الألفاظ. ما في أحد عنده مخ بيستخدم الأوب أمب in this application. Why? Because you're limited with the supply. كأنك بيطلع لك على طول 10 فولت. كأنك يا أبو زيد ما غزيت. You need to connect other components so that you utilize an open loop gain to drive voltages و little currents go. اللي هي الابليكيشن اللي حنشوفها بعدين. Power supply connection, the real op amp function to operate properly, one or more DC supply voltages must be applied. What's important is the potential difference has to exceed the gain. Okay, ideally, I don't care about it. The only thing I know is مثال مثبت السرعة يا شباب. There is a difference between 144.1, the action you take, or if you are driving 145. 145 minus 144 is 1 speed, which would translate to, let's say, 1 volt times 10,000, it will be 10,000 volts. So the controller will take aggressive actions to fix. But if you're only exceeding with 0.1, the controller has only 100. Is it enough to drive the controller? Not really. Always in instrumentation, the bigger the error, the more aggressive actions you take. انت جبت الريد في الميجر, more aggressive action ايش؟ ذاك الميجر 2. If you do well in the major 1, you really don't have to study hard for major 2. وهذه أشياء يعني we as a human we tend to develop it without thinking, naturally. Inverting amplifier. What does the word invert?
عكس.
No. Yeah, it's X, but in that context. Flip. What does flip in terms of phase shift?
يعني ما نضخم عكس ضخم.
Means you multiply with the negative one.
180 degrees.
180. Multiply by negative one. So why we call it inverting amplifier? ليش؟ لأن الأوتبوت بيطلع بالسالب. متى يطلع الأوتبوت بالسالب؟ لما يصير الانبوت على السالب أكبر من الانبوت على الموجب. بمعنى إذا عندك الانبوت هنا 5 وهنا 4 يصير 4 minus. Okay. This is minus 5. Okay. This is 4. What's the difference? Or this is 4 and this is 5. 4. Okay. This is 5 and this is 4. What's the difference? Minus 1. Then if you make sure إنه the difference is negative, the output will be. فالinverting amplifier يعني سالب. It doesn't mean it will invert numbers. يعني 5 يعطيك 1 over 5. No, that's wrong. Inverting amplifier means it will give you a negative signal. So inverting because the input signal is supplied to the negative inverting terminal. We're supplying the negative input. Op amps are almost always used with a negative feedback. The output signal is returned to the negative inverting. So the output signal is connected via a resistor back to the negative input. الحين احنا هنا بدينا نتكتك شوية بالأوب أمب. كذا open loop gain. قلنا ما حد يستخدم الأوبن loop gain صح؟ Now we are connecting the output, we're returning it back to the input. So what do we have in this circuit? But let me read the text and then we go analyze the circuit. Positive feedback is also possible, but negative feedback is always more useful. Because negative feedback, it will correct the action. Positive feedback, it will enhance the action and let it slip further. Get it? ذكروا مثال السرعة. If you're driving 143, what's the negative action? You increase the speed so that you go closer to the reference. Positive action will drive you further. Would be 140. ببطئ لما السيارة توقف. We don't want that. We want negative feedback to connect closer to the original reference point. Okay? Negative feedback, for example, the temperature thermostat stabilizes the temperature to 25 degrees. Positive feedback will not help. It will make the room either freezing or boiling. There is another important point, what we call the summing point constraints. This forces the voltage difference between the inverting and non-inverting inputs to be zero. Because the input impedance of the op-amp is infinite, input current to the two terminals is 0 amp. What did I tell you? There is no current flowing inside. If there is no current flowing inside, what's the voltage drop here? 0. Because no current. We're connecting a short circuit to the ground. 0. What's the input voltage here? Now we use the summing point constraint. For some reason, technical reason, the op-amp would try to make the voltage difference if we connect the feedback. Because of the feedback, it will try to make the two voltages equal. بمعنى the voltage here virtually equals to 0 volts, okay? You have a class? What time is it? Okay. So let's continue next lecture. But we remember about the op-amp, okay? Watch YouTube. Any question? Who did not pick up the quiz? Stop the recording.